So previously we have discussed how the electrons and protons were discovered by cathode ray tube experiment and anode ray experiment, and we have also compared the values of charge, mass and charge to mass ratio of electrons and protons, and we have correlated these values. Now we know the negative component of an atom is called the electron and the positive component of an atom is called the proton. Now we need some atomic model. So the earliest atomic model was Dalton's atomic theory, which we have discussed. Now we will discuss the next atomic model which called the Thomson atomic model. What was the Thomson atomic model? I have said this was called the plum pudding model or the raisin pudding model, or the watermelon model. The plum pudding model or the watermelon model. What did Thomson proposed? That if the atom is a sphere like a pudding or like a watermelon, then the electrons are small negatively charged particles which are embedded in a uniform positively charged cloud. You can imagine it like the seeds in a watermelon. The seeds are electrons, they are negatively charged and they are embedded inside the watermelon, and the watermelon as a whole is a uniform positively charged particle. So if we imagine a watermelon, then its density and texture are uniform throughout its body. So it was also proposed that the positive charged cloud is uniform throughout the atom. The model somewhat looked like this. If this is the sphere, these are negatively charged electrons inside, and it is the uniform positively charged cloud. Uniform positively charged cloud and negatively charged electrons embedded inside the sphere, and this was the spherical atom. So in this model, the positively charged cloud was considered as the pudding and the negatively charged electrons were considered as plums. So as we can see that this plum pudding model of J.J. Thomson had various drawbacks. The first drawback was the structure was not well defined. The electrons are embedded inside the positive cloud, but in what order or how are they arranged? He said that the electrons are randomly embedded, but that doesn't explain the behavior of an atom properly. Also, the electrons are not movable then. We will see what are the drawbacks of the plum pudding model. The first one was mass of atom was considered to be evenly spread. What later experiments showed that maximum mass is in the center of the atom. The second point was it was a static model. That is, the electrons are not movable. So, in this model, the atom was considered to have its mass evenly distributed. But later on, Rutherford's gold foil experiment and other experiments showed that the mass of the atom is concentrated at its center, and also this was a static model. J.J. Thomson himself had discovered electrons. In that experiment, he had shown that electrons split up from the atom in presence of electricity in an electric field, and it moves towards the positive electrode. Also, it showed deflections in the presence of electric field and magnetic field. But from the plum pudding model, the movement of electron couldn't be explained because the electrons are embedded within the positive sphere, so they are not movable. They cannot be extracted out of the atom. The third point was couldn't explain difference in stability. It was seen later on, when more and more elements were discovered, that not all atoms are equally stable. Some atoms of some elements are more stable, whereas different other elements are less stable. So, the difference in stability was also not explained by the plum pudding model. Later on, when neutrons were discovered, the plum pudding model was altogether rejected, because the discovery of neutrons stated that there are some neutral particles too in the atoms, which the plum pudding model didn't state. So, now we will study about the discovery of neutron. But before studying the discovery of neutron, we need to explain some kind of particles which are emitted by the radioactive elements. They are called alpha particles, beta particles and gamma rays. So, what are the radioactive elements? There are certain elements which are unstable in its original form, but they emit some kind of radiation to form a stable atom. So, this emission of certain particles to attain the stability is called radioactivity. Radioactivity comes from the active emission of radiation from an element to convert itself into a more stable different element. So, there are three different types of rays: alpha particles, beta particles and gamma rays. So, what are alpha particles? Alpha particles are positively charged helium particles. Helium 4, 2. This is the alpha particle, where 4 is the mass of helium and plus 2 is the charge of the alpha particle. And the second one are beta particles. Beta particles are nothing but electrons. It is written like this, where 0 is the mass of electron. We know that 0 is not actually the mass of electron. The mass of electron is 0.000548 AMU. This is the mass of electron actually, but this is so small that it is considered to be 0. Okay, and -1 is the charge of electron. We know the exact value of charge of electron, but this is treated as the unit charge, so it is considered as -1. And gamma rays. Gamma rays are not particles. They are electromagnetic waves or electromagnetic radiations. Just like X-ray, visible light, radio waves, UV, IR, all these are electromagnetic waves and part of the electromagnetic spectrum. So, gamma rays are also a part of the electromagnetic spectrum. The wavelength of gamma ray is around 10 to the power minus 13 to 10 to the power minus 11 meters. So, this is in picometer range, PM, that is picometer range. Okay, now we have these three particles, alpha, beta and gamma. The beta particles are of course lighter than, very lighter than alpha particle by mass. Gamma rays are of course not particles, and for the penetration ability, gamma rays are higher. Gamma rays have the highest penetration ability, followed by the beta ray and then alpha. Okay, so after we have studied about the difference of alpha, beta and gamma rays, now we will talk about the discovery of neutrons. So, in 1932, James Chadwick discovered neutrons by bombarding a beryllium sheet with alpha particles. So, we will see the reaction. Discovery of neutrons in 1932 by James Chadwick. What did he do? Bombarded 13 sheets of beryllium with alpha particles. So it was like this: beryllium has a atomic number of 4 and atomic mass of 9, plus alpha particles are helium with atomic mass 4 and atomic number 2, and one atom of carbon was formed. Carbon has a mass of 12 and an atomic number of 6. Now if we equate the mass, 9 plus 4 equals to 13, right? But here carbon has a mass of 12. So what is left? 1 is left. So there must be some particle, X for example, whose mass is 1. And if we equate the charge or atomic number, what we see, 4 plus 2 equal to 6, and carbon has an atomic number of 6. So the other particle that was emitted has to have a charge of 0. Charge of 0 means it is neutral. So Chadwick observed that the particles that were formed after this experiment, that is after bombarding beryllium sheets with alpha particles, was a neutral particle. These were named as neutrons. Neutrons, N01. It is written like this. So let's write the reaction again. So this is the reaction. The similar reaction was done with boron also. Boron has a mass of 10 and atomic number of 5. When it was bombarded with alpha particles, it formed nitrogen. This isotope of nitrogen had a mass of 13 and atomic number of 7 and 1 neutron. So this was how neutrons were discovered. Now the mass of neutron was found to be 1.675 into 10 to the power minus 27 kg, and charge of neutron was 0. So naturally charge to mass ratio of neutron was also 0. If we calculate the value of neutron in mass of neutron in AMU, it gives 1.008 AMU. So we see that the mass of neutron is slightly greater than the mass of proton. Often mass of neutron is considered equal to mass of proton, and since this is 1.008 AMU and this is 1.007 AMU, so both are considered as 1. So ultimately what is this? Mass of neutron and mass of proton are equal and very, very greater than the mass of electron. So we get the 3 components of atom. Electron are negative, proton are positive, and neutron are 0. So now we know the 3 particles of atom: electron, proton and neutron. Thank you.